the chairman, committee, and my dear friends. Good morning, everyone. Today, we are going to present the senior project in the topic of design and comparison of transfer structure for supporting discontinuous column by using the Hyatt Regency building in Phnom Penh, Cambodia as a case study. This is the outline of this presentation that show about the content.
This is a model of the building that we use to design the transfer structure. At the second floor, there is the meeting suite that provides large free space from removing the middle column. We will have to look for the best type of transfer structure that can handle and transfer load from upper floor to near column. The transfer structure that will be considered in this project, which are the recommended by company, that are reinforced concrete beam, steel truss, and plate girder. We will compare the result in the form of self-weight, deflection, and solidity ratio, which is the occupied area to gross area. These are main factors that the owner will consider what type of transfer structure they want to use. The scope of the project. Design of the steel truss and plate girder are in accordance with AISC 15th edition, and design of reinforced concrete beam is in accordance with ACI 318. Consider only gravity load in the calculation. Exclude part of connection. Design under assumption that slab has enough stiffness for basing the transfer structure. Using ETAP software for modeling and analyzing the building. Design under load control by Thai Ministerial Regulation for Building Control Act.
In this project, the effect of construction sequence is taken into account, so construction sequential analysis is used instead of conventional method because assumption of conventional method is that gravity loads are fully applied after the end of construction, while in actual practice, building is constructed and load are applied story by story by effect of creep and shrinkage due to sustained load, make difference in result of stress and bending moment for design, especially for high-rise building, because higher building provide larger difference.
For concrete structure, it is designed as a general reinforced concrete beam in strength design method. Additionally, there are some recommendations from cooperating company for typical detail. The design consists of flexural, shear, and skin reinforcement and this is the positions of each rebar. According to truss system, four types of truss system are used to study and design. There are pad truss, pole truss, K truss, and the walling truss. They are designed in LRFD method by the demand capacity ratio around 90% to 100%.
Plate girder is a combination of steel plates in form of big I-beam to respond the required load. Slender shape of plate girder increase area moment of inertia, which is considered to resist bending moment. Otherwise, stiffener is also considered to strengthen the structure. While the intermediate stiffener is to increase shear capacity at web. Bearing stiffener is to improve the bearing capacity where the concentrated load located, or the position that web failure occurs.
For methodology, there are 5 major stages that consist of 1. Modeling, 2. Load assignment, which refer to Thai Building Control Act, 3. Structural analysis in software with function of construction sequential analysis, 4. Design state, and 5. Result comparing. This slide shows the modeling state. We will model in finite element software, which we select ETAP 2018 and use the load from software to design transfer structure. In analysis part, the building has been modeled from third floor to roof. The reason that we start modeling from third floor because it is the floor where transfer structure located, and fourth floor to roof to get vertical load that act on transfer structure. The model includes structural elements that affect the vertical load, which are beams, floors, walls, and roof. After the model analysis, the vertical load that will act on the transfer structure will be in form of axial force in column. The load combination used in this analysis is 1.2 dead load plus 1.6 live load plus 0.5 roof live load, which is the combination that gives highest axial force when the analysis is run with construction sequential analysis. The axial force in the interested column is 793 tons. That has increased by 5% compared with conventional method that is 757 tons due to the involvement of deflection. So the axial force or vertical load of 793 tons has been selected to design reinforced concrete beam, truss, and plate girder section.
For the reinforced concrete beam, there are 5 module sections designed, different in size and reinforcement detail. For all sections, the spacing of stirrup bar is 15 cm, and use this spacing along the beam, since the slightly decrease of shear force provides that shear at midzone and the end zone are almost the same. And the longitudinal bars are designed as the skin rebar for preventing crack surface. We select 2 most effective sections to discuss in this presentation. The first section is 3 meter depth section with the 1.2 meter of width. It requires 4 legs of DB16 stirrup bar and along span, and the nominal fractural capacity is around 4,800 tons meter, and the shear capacity is around 700 tons. The second section is the section that we exchange the depth of section to be the same as story height or 4 meter, with the width around 0.9 meter. The nominal fractural strength is just less than 4,000 and 1,800 meter, but the tension rebar is less than the previous one. The stirrup bar is 4 legs of DB16 and spacing is 15 cm either.
The trusses are designed in different number of panels by depending on geometry of each pattern. All cases are designed with the same condition that truss occupies a full story height, 4 meters. The standard for controlling efficiency of each section is demand to capacity ratio, which should be close to 1 as much as possible. Due to long span and huge load, the build-up hollow square section is considered with dimension from 200 to 800 mm by increment of 25 mm. Overall, the higher number of divided panels provide a heavier structure for every pattern, so fewer panels seem to be suitable option for truss design. These are examples of dimension and DC ratio of each pattern: pad truss, pole truss, K truss, and Warren truss. Page girder is designed for 2 cases, 2.5 and 4 meter depths. By depth of 2.5 come from practical ratio for design and full story height for 4 meter depth. There are strength and detail of depth, but in this case, due to small area of web section, a lot of intermediate stiffeners are installed to compensate shear capacity. The intermediate stiffeners are located at every 30 cm. A number of stiffeners cause large increment of structure weight and difficulty for construction. There are strength and detail of this case. Due to larger area of web section, less of intermediate stiffeners are installed. The intermediate stiffeners are located at every 3 meters, which is longer than case 1, and the weight is reduced almost 20%. So, regardless of void space and appearance, occupying full story depth seems to be a suitable alternative.
In comparison of results, first is self-weight. Reinforced concrete beam has the most self-weight, while truss have the least. Second is solidity ratio. Truss are the only type of transverse structure that can provide void between sections. Reinforced concrete beam and page girder has to reduce height to provide void space. Finally is deflection. RC beam has the least deflection and followed by page girder and truss respectively. For conclusion, this is the table that includes all subjects used for comparison. It can clearly see that reinforced concrete beam provide the least deflection among all 3 of the structure, but exchange with heavy weight from concrete weight that might affect other structure. So it might need larger size of column or foundation to handle the weight. Truss can provide lightest weight due to the weight of steel that lighter than concrete and less amount of steel element used than page girder. Truss also has the most void space between sections that can use to installing pipe electric system or other decoration purpose. Page girder is a moderate choice when self-weight and deflection are considered. Page girder is lighter than reinforced concrete and has less deflection than steel truss. Truss page girder would not be the best option among other 2 alternatives. Thank you for your attention and thank you My Heart Thailand for cooperation.